Consider a bag of 15 billiard balls numbered 1, 2, 3 all the way up to 15. If 5 balls are drawn without replacement, find the probability mass function of x, the second to largest number selected. So I'm going to start this out with a realization. In other words, I'm actually going to just make up draws of 5 balls from the bag. One thing that you could get when you draw 5 balls from a bag of billiard balls like this, you could get a 4 and then a 1 and then a 13. You can't repeat numbers because they're drawn without replacement. So maybe then you get a 6 and then you get an 8. I'm going to rewrite those, ordering them because order seems to be important here. They are 1, 4, 6, 8, and 13. And the random variable x here is the second to the largest number selected. So in this case, the random variable x assumes the value 8. Now let me go ahead and put some blank positions here for a more generic version of this. And these will be the 5 numbers in sorted order, and we're going to put the smallest on the left and we'll put the largest on the right. And in this position right here, we're going to put x, whatever that x value is there, as the second to the largest. And if there is an x that appears there as the second to the largest, then in these 3 spots that fall to the left of x, we have x minus 1 choices that we can fill those 3 spots with. And for this last value here, if there's an x as the second largest, for example, if there is an 8 as the second largest, then we have 7 numbers that are above 8 here that we can use for the largest number. So in this case, we have 15 minus x choices for the number that will appear above x. So now we come down, try to put together our probability mass function. First thing that we usually do is try to figure out what the support is. What is the smallest number that can appear here? Well, if we happen to get a 1, 2, and a 3 in these first 3 positions, then x could be as low as 4. So it's 4, 5, 6. How large could it be? Well, if we happen to get the 15 ball in the sample, then there's a 15 here, and potentially this value right here could run as high as 14. So there's the support, and now we're going to find the probability mass function. Well, in the denominator there are 15 balls, and we're selecting 5 of them, and the order that they get pulled out of the bag really doesn't matter at all. If this order would have been, for example, 6, 8, 4, 1, 13, order would not have been relevant. So we have 15 choose 5 different samples that we can take of 5 balls. To take care of these 3 balls that are to the left of x, there are x minus 1 choices there, and we're choosing 3 of the balls, in this case 1, 4, and 6, to fill those positions. Now here's something that really isn't necessary, but I'll go ahead and include it. 1 choose 1 is dealing with the 1 ball that we are putting, the single ball that we are putting in the second largest position. And finally, the last thing we have to do here is out of the 15 minus x choices for the number of the ball that is above, that is larger than x, we choose 1. And there is the probability mass function. Now when I do a little bit of algebra, when I write out these combinations, it turns out in the R code here, x will run from 4 up through 14, and that is the support. And f will be x minus 1 times x minus 2 times x minus 3 times 15 minus x divided by 18,018. And when you plot that probability mass function using the type equals h argument to get them as spikes, here is the probability mass function of the second to largest. Notice in our realization we got an 8, and that's actually smaller than average. That's kind of a bit out in the left-hand tail. And notice the most likely value, which we'll define a little bit later as the population mode, is 12 is the most likely value for you to get.